Welcome to Geometry Core Skills for 11 Plus Exam Part 1. Triangle Inequality. This inequality says that the sum of any two sides of a triangle must be greater than the third side. For example, take a look at the triangle below where A, B and C represent the sides of the triangle. Then, according to the inequality, we must have A plus B greater than C, A plus C greater than B, and B plus C greater than A. Let's solve a few questions based on what we have just learned. Let's start with this question. Is it possible to form a triangle with the following measures? How can we know whether it's possible to form a triangle? Do we get a ruler and a pencil and try to draw this out? Well, that would just take too long to answer. Well, we have a simpler method. We just need to check whether the triangle inequality holds true for the three given sides or not. Let's see how to do this. First, assume the value of A as 11, B as 12, and C as 12 again. Now let us compare A plus B and C. So when we compare A plus B and C, we have 11 plus 12 on one side and 12 on the other. And since on adding we get 23 and 12, we can see 23 is greater than 12. So we can write A plus B is greater than C. Similarly, let us check for B plus C and A. We get 12 plus 12 and 11. Upon further simplification, we get 24, which is definitely greater than 11. So we have B plus C greater than A. Lastly, let us check for A plus C and B. Upon substitution, we get 11 plus 12 and 12, which gives 23 being greater than 12. This implies that A plus C is greater than B. Now, this means that each of the triangle inequality conditions are satisfied, and so such a given triangle is definitely going to be possible. Seemed easy enough, isn't that so? Question 2. Is it possible to form a triangle with the following measures? Let us begin with part A. First, we label the sides as A, B, and C. Now, we shall check for the inequalities. Let us check for A plus B and C. Using the values of A, B, and C, we get 5 plus 2 and 1. Or we can say that 7 is greater than 1. Thus, A plus B is going to be greater than C. Now let us check for B plus C and A. We get 2 plus 1 and 5. Or we can say that 3 less than 5, giving us B plus C less than A. But for a triangle, it must be the opposite. Thus, such a triangle is not going to be a possible one. Similar to this part, let us solve the next one. We first label the sides as A, B, and C. Then we check for the condition A plus B and C. Upon substitution, we get 6 plus 6 and 12. Or we can say 12 equal to 12, meaning that A plus B is equal to C. Again, such a triangle is not possible either. Question 3. If the lengths of the two sides of a triangle are 6 cm and 4 cm respectively, then the possible length of the third side is what? Don't worry, the problem is not that difficult as it looks, and again we have options to help us through. As usual, let us first assign the value to A as 6 cm, B as 4 cm. Now let us see the triangle inequality and use it 3 times. According to the first condition, A plus B is supposed to be greater than C, which implies 6 plus 4 greater than C, which in turn gives us 10 is greater than C. Or we can also say C is lesser than 10. According to the second condition, B plus C is greater than A, which implies 4 plus C is greater than 6. Or we can write this as C is greater than 2. And in the last condition, what we have is A plus C greater than B, which implies 6 plus C is greater than 4. Or we can say that C is greater than negative 2. Combining the three conditions, we can write 10 is greater than C, which in turn is greater than 2. You must be wondering why we use 2 instead of negative 2. Since any number which is greater than 2 is also going to be greater than negative 2, The lower bound is set by 2 and not by -2. Once this is clear, we can now check the option satisfying the condition. As it turns out, the possible length must be 9 centimeter according to the options. Thus, we can say that option B is correct, and so the possible length for the third side is option B, which is 9 centimeter. Question 3. Two sides of a triangle have lengths 10 centimeter and 12 centimeter. James suggests some possible values for the perimeter of the triangle, that is 23 centimeter, 30 centimeter, 45 centimeter, and 44 centimeter. Which of James's suggestions could be correct? Well, the first step is that we assign A equals 10 centimeter and B equals 12 centimeter. Now, we are familiar with the triangle inequality theorem. So, what we do next is A plus B should be more than C, implying that we get 10 plus 12 to be more than C. That means that 22 should be more than C. That is the first observation. The second observation that we have is A plus C should be more than B. Therefore, 10 plus C is more than 12. Thereby, C should be more than 2. The third observation that we can have is B plus C should be more than A. So 12 plus C should be more than 10. That is why C should be more than -2. Combining the three observations, we can get the range of the values of C, that is the third side, is between 2 and 22. Now you might be wondering that where exactly did the third observation go away? So if you think logically, all the values that are greater than -2 can be clubbed over here. If we take the value -1, which is again greater than -2, we cannot have that as the side length. Likewise, 0 is another value which cannot be taken here. Now, since C is supposed to be greater than 2, taking C greater than -2 combines both the situations. That is why the range for the third side has been taken between 2 and 22. Now that we have the range for the third side, that is C is supposed to be greater than 2 but lesser than 22, we now find the range for the perimeter for which we are assigning the variable B. Now, what we can do over here in order to find the range is, we get A plus B plus 22 greater than B greater than A plus B plus 2. Upon plugging the values of A and B, we get 10 plus 12 plus 22 greater than B greater than 10 plus 12 plus 2. Upon simplifying, we get 44 greater than P greater than 24. When we compare the given values which James suggested as the possible values for the perimeter, we can see that 23, 45 and 44 do not fit the bill, but only 30 centimeter does. That is why we can say that option number 2, that is 30 centimeter, is the correct answer. So our final answer is going to be option 2, which is 30 centimeter. After understanding about inequality in detail, let us discuss about one of the famous theorems in mathematics, which is the Pythagoras Theorem. This theorem states that for all right-angled triangles, the square of the hypotenuse is equal to the sum of the squares of the other two sides. The hypotenuse is the longest side and it's always opposite to the right angle as shown in this diagram. Let us see this statement with the help of algebra. We can mark these sides as A, B, and C. Can you locate which one of these is going to be the hypotenuse? Yes, you're absolutely correct. Here we have a right angle and this is the side opposite to that of the right angle. Thus the hypotenuse over here is represented by the letter A. In this triangle, according to the Pythagoras theorem statement, we can write this as A square equal to B square plus C square. Why? Because angle A over here is the right angle. Remember, Pythagoras theorem only works for right angle triangles. Now that we have understood about Pythagoras theorem, let us practice this question. Find the length of the diagonal AC. Since ABCD is a rectangle, BC is going to be equal to AD, which is equal to 5 cm, and AB will be equal to 12 cm. Applying the Pythagoras theorem, upon the right angle triangle, which is ABC, we get AC square equal to AB square plus BC square. Using the values of AB and BC from above, we get AC square is equal to 12 square plus 5 square, which is then equal to 144 added to 25, which is equal to 169. Now, we have 169 as the square of 30. So we can write this further as AC square equal to 13 square. This implies AC being equal to 13 centimeter. So the length of the diagonal of the rectangle ABCD, that is AC, is going to be equal to 13 centimeter. Knowing about the Pythagoras theorem, let us see how it can also be used to solve three-dimensional problems. For example, we have a cuboid as shown below. Suppose we wish to find the length of the diagonal AC. The length of the diagonal AC is from the point C to the point A. Then we can do this by applying the Pythagoras theorem to the triangle ABC as shown. We get AB square plus BC square equaling to AC square. Pretty simple, isn't it? Question 5. Find the length of the diagonal AD, which can be seen in the diagram marked in the blue line. Now what we do is, we take the triangle A, C and B, which happens to be a right angle triangle since it is a part of a cuboid. So, applying the Pythagoras theorem, we get the equation as follows, which is AC squared is equal to AB squared plus BC squared. We know the value of AB as 6 and BC as 2. Let's plug in. So we get 6 squared plus 2 squared, which gives the value of AC squared as 40. Now let us take the triangle ACD, which is yet again a right angle triangle. Upon using the Pythagoras theorem in the triangle ACD, we get AD squared is equal to AC squared plus CD squared. Plugging in the values, we get 40 plus 3 squared, which in turn gives us 49. Or we can rewrite this as AD squared is equal to 7 squared, which in turn gives us AD being equal to 7 centimeters. Thus, the length of the diagonal AD is going to be equal to 7 centimeters. Let us now solve problems based on everything that we have learned so far. Question 1. Length of a rectangular frame is 12 centimeter. If the length of the diagonal is 13 centimeter, then what is the area of the frame? Well, let us infer from the question the values known to us, that is, AB is equal to 12 centimeter and AC is equal to 13 centimeter. Moreover, we can see that ACB is a right angle triangle. Using the Pythagoras theorem, we can write AC square is equal to AB square plus BC square. Let us rearrange this equation so that it looks like BC square being equal to AC square minus AB square. Now we have the values, so we better plug them in, and what we get after that is 13 square minus 12 square is equal to BC square. Thereby, we get BC square equal to 2525. So we can write that BC is equal to 5 centimeter. Now we have been asked to find the area of the frame. So what we do over here is that the area of the frame is equal to AB times BC, that is the length times the width. So this is going to be equal to 12 times 5, which in turn gives us 60 centimeter square as the answer. Thus the area of the frame is going to be 60 centimeter square. Question 2. John walks 3 kilometers east and then turns right to move 4 kilometers more in a straight line. How far is John from his starting position? Well, in order to understand how to work this question out, we need a reference diagram. So let us mark the initial position of John as A. Now, since he walks 3 kilometers east, it is going to be in this direction, where his position is marked by B and the distance is marked as 3 kilometers. Up next, he takes a right, so that would be in the south direction, like this. Marking this, we get it 4 kilometers and placing a C over there, and then turning this into a right angle triangle, we get a diagram like this. Now that we have the diagram, let's see what we can do. So what we do over here is that by using the Pythagoras theorem, since this is a right angle triangle, we get AC square is equal to AB square plus BC square. Thus, we get 3 square plus 4 square equal to AC square. Thereby simplifying, we get 9 plus 16. So the addition is 25, and therefore AC square is equal to 5 square, which in turn gives us AC equal to 5 kilometers. So John is 5 kilometers away from his starting position. It's now time to test ourselves. ABCD is a straight line. Triangle ABF is equilateral. What is the size of X? Press pause on the video for now. Take your time. Try to work out the answer. Then press play when you are ready to check your answer. Did you get the answer as X equals 50 degrees? Great. Well done. Congratulations on successfully completing the module on triangles. With this, we move on to the next step. Next, what we need to do is, we need to do worksheet 1 to 11, homework 1 to 4, and mental maths test 1 and 2. So, these are all the worksheets and all the steps that you need to perform in order to make sure that you have completely understood everything discussed in this module. So, that was all for today. We shall see you the next time. Bye-bye.
If you like this video, please make sure you click the like button, and if you have not subscribed to the channel yet, please do it right away. To access the full 11 plus geometry course, please visit the link provided in the description below. You can avail an additional 30% off on this course by using the coupon code YouTube30 during checkout.